So good evening to all present in the live session. So my name is Ganesh Shankar Bhandari and I am a PMRF scholar who is going to take the live sessions for the course Municipal Solid Waste Management taught by Professor Ajay Kalam Dahab from IIT Guwahati. Okay, so can you please mute off all your all of you can mute your systems. Okay, can you see the screens? Hello, are you able to see the screen?
Yes, yes.
Okay, thank you. Okay, so we will wait for 4 5 minutes. We will see if any other people joins. Then we will start. Okay. we will start now. So, this is going to be a live session for problem solving. You will get your in your assignments. So, in each live session, I will briefly introduce you with the topics whatever you have read in last weeks in your last week of course. So let's start with the session for first week. So we will go with a brief introduction, whatever you have read in your first week lectures. So coming to the solid waste. So what is solid waste? Actually, it is like whatever the useless things we are throwing away in the dustbins, these are called as a solid waste. Okay, so these can be heterogeneous mass or that can be homogeneous accumulation according to in agriculture or industrial wastage. You are going to create a homogeneous accumulation of the waste materials, or in the households you are going to create a heterogeneous mass which can contain everything like your kitchen waste, your electronic waste, or everything whatever you are throwing away in the dustbins. Okay, so some of the there are some synonyms which are also used for the uh, solid waste material. Like one is refuse. This is a more appropriate term for solid waste as more waste can be utilized as a raw material for some other purpose. Okay, then coming to the garbage, it mainly consists of your kitchen or wet waste which contain high amount of moisture around 80 to 90%. Then one more term is rubbish. Uh, these are the waste which contains very high S content. Like if we are talking about the paper waste or something, your poly bags or cloth material. So these are the types of waste which are going to create high S content. Okay, or if we are talking about agricultural waste, those are also going to create very high S contents. Okay, then coming to the scrap material. So scrap materials are those materials which contains high metallic content, which can be directly recycled via smelting or melting processes. Okay, so these are mainly the waste which can be directly recycled without any further treatment. And then coming to one more term, that is debris. Okay, so debris is basically consist of the construction waste, or when the sweepers are going to sweep the streets, then it will contain more of the debris type of waste content. Okay, that will contain your dust content, very high dust content. So it will be having very less amount of as material, or you cannot use it directly in some uh, to create some useful materials. Okay, that you have to go for landfills or something like that only. Then coming to the so why solid waste is consequences of what are the consequences of generating these solid waste? Okay, so these the improper disposal of these waste can cause health hazards. Okay, like that can be a home for many unwanted creatures like rats, fleas, or disease vectors. Someone want to say something? Okay, so that can create many type of disease like plague or dengue, malaria, like those disease. Okay, and improper landfilling of these solid waste also attribute to the water pollution, because these types of waste sometimes contains some heavy metal contents, and when they are going to contact with water, then they are going to react with water and going to create water pollutions. Okay, so as we all know, in the drinking water we don't need many heavy materials. Okay, there are some limitations of heavy materials inside the drinking water contains, and if we are going to improper landfilling of these solid waste, then this is always going to create water pollutions. And the improper landfilling or burning or combustion of these waste are also going to create some greenhouse gases like CO2, CH4, or some fluorine gas emissions also will be there. And sometimes if we are going to burn the plastics itself, then we are going to create a lot of bromine and fluorine content in the gases that are also harmful to the human health. Okay, then coming to the how these managements of municipal solid waste has arrived, come need for managing these solid waste has arises in India. Okay, so first instance was created during the plague, which was observed in the Surat, Gujarat. Then they had created some rules regarding the municipal solid waste management. The Surat was the first city to create some municipal solid waste management rules for the proper disposal of this MSW. Then that municipal solid waste handling and management rules came in during 1987. After that, one of the philanthropist, Dr. Almitra Patel, has filed a PIL at Supreme Court regarding to create some MSW rules for that can be followed in all over the India. Then came JNNURM 2006 from Guwahati. Then during the first tenure of Modi government, they have started Swachh Bharat Mission 2014, and after that, a long fight, we had finally got our first management solid waste management rules in 2016. Then there are many types of there are different types of solid waste that can be broadly classified into three different categories. First is municipal waste, which generally includes garbage, food waste, ashes or residues, construction or demolition material, and whatever the plant waste or agricultural waste that is going to created, which is not useful. Then coming to industrial waste, this type of waste includes effluent materials generated during different processes that can be liquid or solid waste, and that can be very harmful because these industrial waste generally contains high amount of heavy metals, and they can be highly acidic or highly basic in nature. So the treatment of these industrial wastes are important. Then third one is hazardous waste, which includes which can be liquid, solid, gaseous, or sludge, and in any form, and that are dangerous or potentially harmful to our health or environment. These types of waste generally contains like your biomaterial waste, whichever going to create from the hospitals, and your sanitary pads, which you are going to throw away from your households, and many byproducts which are going to created during the as a byproducts from the industries or households. Then after collecting, the collection of these waste are important, and after collection, the treatment of these waste are important. But before going for treatment, we need to analyze the content of these waste, whatever the content of these types of waste. So we need to analyze that content so that we can provide proper suitable we can provide a proper a treatment to treat these waste. Okay, so before going for the treatment or whatever the characterization processes you are going to need, we have to create a proper sample. Okay, because if we are talking about waste, then we are talking about tonnage of materials. Okay, so we can't go for characterization of that tonnage materials. Okay, we need just some maybe 1 kg or sometimes 50 gram or 100 grams of sample for the final characterization processes based on the instrument. Sometimes you only need some milligrams of material in your characterization processes. But how you are going to take that milligram or gram or kg of material from that tonnage of materials? Okay, so here comes the need of sampling methods. Okay, so one of the best sampling method which has created for the mineral processings or for ore samplings or anything you are going to need sampling for characterization, that is quartering method. So in quartering method, first we are going to take some quantity of waste like 100 kg or 200 kg, whatever you are you want to take as a sample from that tonnage of materials. Okay, then we are going to divide that material into 4 quarters, each containing 20. If we are going for 100 kg, then each quarter will contain 25 kg. Then we are going to take two cross sectional sections, like uh, this one and this one. Okay, so these two we are going to take again 25 kg and 25 kg. Then it is going to 50 kg. Then again we are going to divide it in 4 different parts. Then after that we are going to take these 2 parts. Okay, in first session we had taken these 2 parts. Then in second shift we are going to take these 2 parts, 12.5 kg, 12.5 kg. Then again coning quartering, and we are going to do this again and again until unless we are going to take our samples, we need sample of 1 kg or 2 kg. Until then we are going to do this method on a repetitive basis, and that sample will be used for further chemical analysis or physical analysis, whatever you are going to uh, do for the characterization of that particular sample. Okay, and we are going to create around 10 to 30 samples for creating a homogeneous characterization process, and we are going to take the average of that characterization process. So sampling should be done for all 4 sessions. If we divide the session like morning, afternoon, evening and night sessions, so sampling should be done for all sessions and 7 days a week and at least twice in a session. Then coming to the different types of characterization techniques which we are going to do to characterize our municipal waste or solid waste. So first we will talk about some physical characterization, then we will go for some chemical characterization. So first physical characterization method is specific weight of that material. Okay, so specific weight is defined as the weight of material per unit volume. Okay, so why it is necessary? So if we are going to go for landfill or some collection processes. Okay, so in if we first talk about collection processes, so in collection process we need some trucks. Okay, so according to our need we have to define the number of trucks. Okay, and every truck has a defined volume to collect the waste. Okay, so we have to know the specific weight of the material whichever we are going to collect in these trucks, so that we can collect much more amount of waste in a single number of truck. Okay, so uh, that can provide a better economy during the collection process. Okay, so generally higher waste densities is observed in India. We generally observe higher waste densities around 400 to 600 kg per meter cube due to high amount of inert material. So inert material, when we are talking about inert material, it is like debris or construction or demolition waste type of material which is basically inert in nature. Okay, that is not going to chemically react with anything or like that. We just have to go for landfill only. So coming to the different types of waste, so generally food waste contains a specific weight in the range of 130 to 480 depending on the moisture content of that food waste material. Then coming to paper waste, that is generally 40 to 130 kg per meter cube. And that when we are talking about metal waste, so that is going to take a minimum volume. Okay, because we all know that metals has a higher density. So like tin cans, it is going to take a specific weight of around 50 to 160 kg per meter cube, and in case of aluminum that will be 65 to 250 kg per meter cube. So that is we are talking about before compressing that material. Okay, after compressing, that specific weight is going to get more and more after that compression of the waste material. So it is often reported as loose as found in containers, uncompacted or compacted. Okay, so that compacted specific weight is always going to on the higher side compared to your uncompacted weights, and it can vary throughout the season or it can depend on geographic locations or length or type in shortage. Like if we are talking about season of the year, then in if you talk about monsoon, then the waste will contain more amount of moisture content. And if we are talking about summer, then it will contain lower amount of moisture. So your density is going to vary according to your season. Then coming to the one more physical characterization, that is particle size of the material. So particle size is basically defined as the uh, that can be defined with these different equations, like size of the component can be its length only, or it can be length plus width divided by 2, or it can be average of length, width or height of the material. So that we need to determine according to the mechanical means, such as trommel screens. We are going to provide some trommel screens of different size, and we are going to put our waste material in those trommel screens. And if we are for example, if we are talking about a trommel screen of 100 mm, okay, so we will separate the waste according to two categories. One is plus 100 mm, and then second is minus 100 mm material. Okay, so that will be the particle size of the waste material. Then coming to the one more physical property, that is field capacity. Okay, so that field capacity is basically defined as a amount of moisture that can be retained in the waste sample subject to the downward pull of gravity. Like we can see, this is a solid waste, and if there will be a rain, okay, so that waste is going to absorb the water inside that material. Okay, we have compacted the waste material. If we are talking about landfills, generally this field capacity is generally important for landfill. Okay, so whenever we are going for landfill of some waste material, then we will talk about that field capacity. Okay, so after rain, what amount of that compacted waste, what amount of moisture that compacted waste is going to retain, that is known as the field capacity of that particular waste material. Okay, so the field capacity varies with the degree of applied pressure and state of decomposition of the waste. Okay, so as we are talking, that agricultural residue is going to it might going to hold much more field capacity as compared to the debris or construction or demolition waste. Okay, so coming to the coming to some chemical characterization processes. Okay, so in chemical characterization processes, we talk about some different processes. Like we talk about proximate analysis, we talk about ultimate analysis, and we talk about the calorific value, higher heating value, or uh, the gross calorific value of the material. Okay, so if we are going to use the waste materials to create some energy, like in pyrolysis process or like in combustion process, some power plants in India are using the those solid waste as a fuel material if they are having some high gross calorific values. So how we are going to analyze those high gross calorific value or higher heating value of that material? We have to do the proximate analysis or ultimate analysis of the sample. So once we are going to find the carbon, hydrogen, nitrogen and sulfur content of the waste with the help of ultimate analysis process, with the help of CHNS analysis machine, we can easily calculate the GCV or HHV value of the material according to these equations, which is known as Dulong's formula. So these are some and in case of in case of proximate analysis, we are going to analyze the S content. Hello.
Sir, your
In
slide is not changing.
slide is not moving.
Yes, sir, it was not moving. Now it's moved.
Okay, let me check once again. Now it is visible.
Yes, sir, it is visible now.
Okay.
Thank you.
So coming to waste characteristic, one is compositional analysis. We are going to create some physical. We are going to separate our waste material according to some physical properties like that can be dry waste, wet waste, which contains high amount of moisture. We can create paper, glass, metal, household hazardous, construction or mixed or miscellaneous type of waste according to their basic physical properties, and they are weighed and are represented as a fraction of the total waste. Then what are the importance of these compositional analysis? According to these compositional analysis, we can create a separate stream for the treatment of those waste. Like if we are talking about dry waste, that dry waste can be used as a fuel material for power plants, or if we are talking about wet waste like that majorly contains the food waste material or kitchen waste material, uh, from that waste we can go for some anaerobic digestion process to create ammonia gas or CH4 gas that can be directly reused as a fuel material. Okay, and in case of metal, those metals can be directly recycled via melting or smelting processes. Okay, then so these are the importance of the composition analysis of the waste. We can design some disposal facilities according to the physical properties of those waste. Then coming to the chemical properties of the municipal solid waste, we talk first we talk about the that importance in alternating processing and energy recovery options. So we need the proximate analysis. So with the help of proximate analysis, we are going to analyze four different things. First is moisture. First is moisture content. First is moisture content, then volatile matter, ash content, and then fixed carbon. So why we are talking about moisture content? So if we are talking about moisture content, okay, so if we are talking about kitchen waste that contains very high amount of moisture, around 70 to 80%. So that waste cannot be directly reused as a fuel material. Okay, you have to remove that moisture content from that waste. Then only you can go for some pyrolysis process or some combustion processes for that. So according, so instead of going for that instead of going for pyrolysis process or combustion process, we can design some separate process. Okay, like we can go for anaerobic digestion process because that contain very high moisture amount. So we can go for some anaerobic digestion process. So whatever we are going to get, what we are going to get, we will get some ammonia formation, some CH4 gas formation. Those gases can also be reused as a fuel material. Okay, so that is the importance of that proximate analysis, why we need to uh, do the proximate analysis of the waste. So in case of volatile material, so proximate analysis of the material can be done by heating the MSW at 105 degrees Celsius for 1 to 3 hours. Then coming to the volatile matter is nothing but when we are going to combust our MSW or any material in inert atmosphere at around 900 or 1000 degrees Celsius. So in when we are talking about inert atmosphere, we are talking about absence of air, like we are providing some nitrogen or we are providing some argon atmosphere inside the furnace. Okay, so whatever the volatile material is present there, that is going to decompose into the gases, and it is going out from the system. So for calculating the volatile matter presence in the MSW, we have to heat it at around 950 degrees Celsius for 7 minutes in absence of air. So for providing absence of air, we can go for nitrogen, argon atmosphere, or we can go for vacuum atmosphere also. After the so why this volatile matter is important? Okay, so when we are going to create a pyrolysis type of things to create fuel material from these MSWs, then this volatile matter contained matters. Okay, so how to higher amount of volatile matter will provide you the higher amount of gases produced during that pyrolysis process, and those gases can be directly reused as a fuel material, because due to the content of carbon or hydrogen, they are going to possess some gross calorific value according to Dulong's formula. We can calculate that. And then coming to the S content, so whatever the residue after complete burning, whatever the residue you are going to get after complete burning of your material, that will be known as S material. So that S content, what the chemical composition of that S content will provide you the content of the heavy metals or metallic particles inside your municipal solid waste. Like if we are talking about iron, chromium, vanadium or something like that, that are not going to decompose or going to convert into gases at how much higher temperature you are talking about. Okay, even at 1500 degrees Celsius, that iron is going to convert into liquid. It is not going to convert it into gas material. Okay, so that is going to create a residue during the burning process, because that is not going to burn out. Okay, so for determining the S content, we have to burn that material in the presence of air at around 750 to 800 degrees Celsius for 3 hours. That process can be completed in any incinerator or furnace, or you can just mass burn your sample in atmosphere. Okay, then coming to the fixed carbon content. So fixed carbon content is nothing but the difference of the whatever the material you are going to get after uh, subtracting S content, volatile matter and moisture content from the total waste of your waste. Total waste, whatever total weight of the waste you have taken. Okay, so why this fixed carbon is important? So when we are talking about to talking about the use of these municipal solid waste in power plants. Okay, so they need some higher fixed carbon content. Okay, in power plants generally we go with the coal burning. Okay, so those coals generally contains around 50 to 60% of fixed carbon materials. Okay, so if your municipal solid waste falls into that category, okay, around 50 to 60% of fixed carbon content, then that waste can be directly reused as a fuel material for the power plants. Okay, so in India, when we talk about Indian municipal solid waste, that contains around that contains a fixed carbon content of around 35 to 40% only. Okay, so if we are going to use them in power plants, then they have to blend it with coal material with higher carbon percentage. So to create a proper efficiency during the process. Okay, then coming to the ultimate analysis. So ultimate analysis is nothing but CHNS analysis. Okay, you are going to analyze the carbon, hydrogen, nitrogen, sulfur and oxygen content in your sample. So that content is analyzed based on dry basis. So analyzing the CHNSO content in your waste, first you have to remove the moisture content from your sample. Then only you can go for CHNS analysis. And on the basis of this CHNS analysis, we can calculate the heating value or calorific value of the waste. So by using Dulong's formula. So coming to the proximate analysis, generally when we talk about the paper waste, okay, so we talk about magazines. Okay, so these magazines contain around 4 to 4.1% moisture content, then a very high volatile matter content around 66.4% volatile matter, and only 7% of fixed carbon. And S content is also very high, around 22.5% S. So energy content will be at around something 10,000 kilojoule per kg of magazines. Okay, so volatile matter is consist of substance formed during heating of waste out of contact of air. There are CO, CO2, CH4, N2, H2O, and other hydrocarbons like phenol or ketones, or other higher chain hydrocarbons like C18, C16 that are going to create during the incineration of the municipal solid waste in the inert atmosphere. So ultimate analysis, as we had already discussed about, it is for the analysis of CHONS and S content for accurate material balance. Now we had gone with the summary of the whatever you have read in your first week lectures. Now we will go with some question answers which are going to help you to solve your assignments whatever you are getting in your after completing your lectures. So we will go with some question answers based on these slides. Okay, so first question is match the following correct answers. So we had already discussed about garbage, rubbish, scrap and debris. So we have to match this. So any answer?
Sir,
Yes.
scrap, garbage is this is contains bulky and this. Sorry,
Okay.
garbage is kitchen waste. Rubbish
Okay.
is second. It contains bulky waste. Scrap,
Mhm.
it has high metal content. Debris, it has ash content.
Okay. So you had told us two are right options, but two are wrong. Okay. So garbage, it is generally kitchen waste as we had already talked about, and then we are talking about rubbish. Okay. So that rubbish is generally is having very high ash content. Okay.
Okay, okay, sir.
So it will having high ash content, and debris will be having construction and bulky materials. Okay, like construction waste. When we are talking about construction waste, that can only go for landfills. Okay, because that will be also containing very high ash content, but we are not talking about high ash content because that will be around 90 to 98 to 99% ash content only. It will not contain any fixed carbon. Okay, when we are
Okay, sir.
talking about debris. And scrap is we already know it has very high metal content and it can be directly reused as a
As
so
a raw material.
yeah, as a raw material in metal industries. Okay, so answer will be when we are talking about garbage. Okay, so that will be kitchen waste. Okay, so it will be like this. Rubbish, it has high ash content.
Ash content.
Your scrap high metal content, and debris it contains high bulky
Bulky
waste such as construction waste.
construction waste.
Okay, so
Yes,
your
yes, yes.
answer will be garbage A third, B fourth. Okay, so answer will be D,
D.
I think. Okay, so coming to next question. The rule currently in practice for MSW management in India is
This is 2016, option D.
yes, we are going with the 2016 solid waste management rule. Before that, we had created some management municipal solid waste management rules during 2000s also on the after the verdict of the Supreme Court on the PIL of some anthropologist. Then in 1980s when in 1987 there were no solid waste management rules, only the Surat city has created some laws according to in their boundaries for for treating that municipal solid waste. And in 2020 we had not, after 2016 we had not got any new rules for MSW management yet. So we are currently going with the 2016 rules only. Then third one, what are the sampling methods for waste characterization?
Quaterning method, sir.
Yes. So quartering method is the sampling method for your waste characterization. So when we talk about proximate method, that is for analyzing the ash, moisture, volatile matter, and fixed carbon content. Then ultimate method is for analyzing the carbon, hydrogen, nitrogen, sulfur, and oxygen content on on elemental basis in the waste material. And cluster method is generally used for the collection process of the material. Okay, so we divide the cities into some clusters, and then we are going to collect the material according to those clusters. Okay, so the
Right,
right
sir.
answer is quartering method. Coming to next question, what types of waste are not included in MSW, and there can be more than one options that can be correct. So
Uh, D number, sir.
okay,
D.
uh, you are talking D. Any more options?
Sir, option B and D.
Okay, option B. So any idea why we are not considering these two answers are right? Because for plastic and papers from school we consider it as a MSW, and road sweepings and dead animals are also considered as MSW. But why we these two are not considered as a MSW? Any idea?
So the pulp and paper is related with the effluents,
Okay.
and it is the industrial waste, sir. Basically, it is the
Yes.
industrial waste, so that's why it is not considered as municipal pulp
Okay.
solid waste.
Yes. Because
And
that
whenever
had
you
to.
go to, yes, sir.
Yes. Yes, that had to be treated by industry itself. Okay, because that contains some heavy metals also, and yeah, the mill sludge or paper pulp sludge can be acidic or basic in nature. So that is the responsibility of industries itself to create a process to dispose of these types of waste. Okay, that is true. And then what about sanitary napkin waste from household? Why we are not considering it is MSW?
Actually, the sanitary napkin, it is not easily disposed of, so that's why it will be not considered, sir.
Actually, it is disposed of generally in households. You are just going to
Yes,
put your
sir.
sanitary napkins in dustbins and like that. So it will go into MSW, but we are not considering it as a MSW
Why, sir?
Uh,
because that sanitary napkin comes under the category of biological waste. Okay, because that is
Okay.
biological waste and it contains some if we are talking about biological waste, then we talk about bacterias and all bacterias, viruses, like those things. So that cannot be treated as a MSW. Okay, you have to create some separate process to treat these sanitary napkins. So these are if they are coming into MSWs also. Okay, so by the after collecting these waste, you have to go for segregation process, and you have to collect the sanitary napkins separately, and you have to provide them some industry you have to provide them to the industries which are treating these biological waste. Okay, because process is very quite different. Okay, for treating the biological wastes. Okay, any doubt?
No, sir. Clear, sir.
Okay. So, coming to the next one, which of the following is not a component of physical waste characteristics? So, we had talked about two characteristics. Okay, one is physical, and the second one
One is
was
chemical.
chemical characteristics.
Chemical. Divide. Approximate to is there a specific weight, particular size? I think, sir, D option.
You are telling D or B?
D, sir.
D.
Field particle.
Sir,
Okay.
option E.
Yes. Option A is right. So, why we are differentiating them in physical or chemical waste characteristic? Any idea?
Okay, sir. Not a.
So in physical characteristic, we are trying to analyze some properties which are physical in nature. Okay, that can be changed according to shape, size, or maybe your geological constants. Okay, that can be changed according to that. And in physical waste characteristic, we are not going to do any damage on the waste. Okay, we are just in case of specific weight, we are just going to compact that way, compact, or we are going to take uncompact material and we are just going to weight it according to some volume. Okay, we are going to analyze the volume of that waste and weight of that waste. According to that, you can calculate a specific weight. In case of particle size also, you are not going to create any destruction on your waste. Okay, and in case of field capacity also, that is similar. But in case of proximity analysis or CHNS analysis or chemical analysis, okay, you are going to destroy your material. Whatever sample you are going to take for that analysis, you are going to destroy that material. Okay, in case of proximity analysis, you are not going to get that material back. Okay, so that's why they are also known as chemical analysis.
बैटरी खाएगा
And one more thing is there, we are trying to analyze the chemical properties of that material. Okay, that cannot be just seen by naked eyes or like that, or you can go with just physical processes. So the proximate analysis is not a physical waste characteristic process. Then coming to next question, the quantity of waste generated in the high income group as compared to the low income group will be more, less, same, or it has no relation with the income group.
Sir, option A,
Uh,
more.
D. It has no relation with the income group.
Okay, so one had answered A and then second has answered D. So any idea why, justification for your answers?
Sir, it is not dependent upon the income.
Okay, I don't think so. And what your justification for A answer, more?
Sir, it is related because they use more packaging material and they buy it.
Yes, yes. They have higher purchasing power. Okay, so they are going to use more materials which are going to create more waste. Okay, one thing is that. And then second thing you can say, like in lower income groups, we generally treat waste as a valuable material sometimes also. Okay, we are going to when we are talking about these municipal solid waste management rules, we talk about segregation of waste. Okay, but when you see sometimes in lower income groups, you are already going to create that separate segregations of the that waste. You are not going to throw away any scrap material. Okay, you will keep it with yourself so that you can use it in near future, although it can in near future you are not going to use it, but in many cases you are going to create the you are going to segregate those materials after you are going to throw them away. Okay, but in case of high income groups, they will say just throw it away, we will buy a new one. Okay, that can be a cause also. So the quantity of waste generated in the high group, income group as compared to the low income group will be more. Okay. Then coming to next one, which of the following elements are not measured in the ultimate analysis?
Sir, option B, phosphorus.
Yes. We can measure hydrogen, carbon, nitrogen, and nitrogen, oxygen, and sulfur
oxygen
content with the
and
ultimate
some
analysis. But there will be phosphorus content also. So how we are going to measure that phosphorus content? Any idea? There will be some phosphorus content. There can be some iron content or chromium or nickel. Like many heavy metals can be there. So any idea how you are going to analyze those elements in your waste? Okay, so there are two routes to analyze these contents in your solid waste. When I say two routes, it's like your starting material can be different. Okay, you have to go with chemical analysis process. You have to dissolve your waste material into some strong acids like a mixture of hydrochloride, and hydrochloric acid and nitric acid. Okay, so that will create a mixture which is known as aquaresia. Okay, so you are going to dissolve your whole material into that aquaresia material, and after dissolving your material into aquaresia, so what will happen? Any of the organic content like hydrogen, carbon or nitrogen, it's not going to dissolve in that aquaresia, but any metal content which is present in your material, it is going to dissolve in that aquaresia material. And after dissolving that material, you have to go for some chemical analysis processes, there are some instrument like ICP-MS or AAS. Generally we in case of solid waste management, we go for AAS, atomic absorption spectroscopy. Okay, so with the help of that instrument, you can analyze the content which has been leached out in that acid. Okay, and that acid is so much strong that it is going to leach out all of the metal content present in your solid waste. Okay, so before going to create the feed material for your solid waste, it is wiser to go with the S content only. Okay, so when we had talked about proximate analysis, we had talked about the removal of volatile matter or your moisture content and S content. Okay, so whatever the metals are present there, ultimately they are going to report in the S material. Okay, so it will be easier to dissolve the S content, because when we are talking about solid waste, if we are talking about 100 grams, so the S content can be in the range of 40 to 50 grams. That can be around 40 to 50 grams. So you have to dissolve much lower amount of material into the acid. Okay, and at last you can calculate according to the mass balances whatever the amount of material is present inside your MSW. Okay, any doubt? Okay, so we will go for next question. After which initiative did the segregation of waste come into practice? उन्नत भारत अभियान, स्वच्छ भारत मिशन, शिक्षा अभियान और वेस्ट मैनेजमेंट पॉलिसी?
B number, sir. Swachh Bharat Mission.
Okay. So after this Swachh Bharat mission, which has started in 2014, that initiation for segregation of waste came into practice. So what are other things? That Unnat Bharat Abhiyan, it is basically mission for creating livelihood in the villages area to provide markets for the farmers in the cities. Okay, that is for that Unnat Bharat Abhiyan that is created from IIT by some professor from I think IIT BHU. He has started this Unnat Bharat Abhiyan, and most of the IITs are attached with this Unnat Bharat Abhiyan in different manners. And then Shiksha Abhiyan, that is just for the education purpose. And that's then coming to waste management policy, that has came after that SBM. SBM had started in 2014, and after that SBM only the segregation of waste came into the practice, and waste management policy came into the practice in around 2016. Okay, then coming to next question, what is the temperature and time required to determine solid waste's moisture content? So we had talked
Sir,
about,
option B.
yes, option B, we need to keep it for at 104 degrees Celsius for 24 hours to remove moisture content from MSW that we had talked about in the proximate analysis process. Okay. Then coming to the next one, which of the parameters are not measured in proximate analysis?
Sir, option D, caloric value.
So how we are going to
Option D.
calculate this? Option D.
Yes, sir.
So how we are going to calculate this calorific value? Any idea? Because that is also necessary.
Through bomb through bomb calibration.
Yeah, you can go with bomb calorimeter. You can
Yes, sir.
directly calculate the calorific value, or for just a approximation, you can go with the CHNS analysis also. So the CHNS analysis is going to provide you the content of carbon, hydrogen, nitrogen, sulfur, and the quantity of those materials can be put into the Dulong's formula, and with the help of that Dulong's formula you can calculate your calorific values, or you can directly go for the bomb calorimeter instrument. You have to put your material into the bomb calorimeter and it will provide you the calorific value of the material. Okay, and rest of three contents we can easily analyze with the help of proximate analysis. Okay, so this is it. So any questions you want to ask? Not the assignment questions which you had got in your first week assignment. Besides that, you can ask if you want to ask something. In the first week lectures, if you had some doubts.
So, sir, just I missed some lectures. So, if I go through then later on, if I wanna ask, so how can I ask you?
You can ask in next sessions also if you want to ask. No problem.
Okay, sir.
There will be session on every Sunday from 4 to 6 p.m. 4 to 6 p.m. 4 p.m. will be starting time, and ending time
So
we cannot.
Sir, I got the link for one session yesterday as well. So was that the same session, or it's both are
No,
the different
actually,
sessions?
there are three sessions. There are three different TAs for three different sessions. So you can join any of the three sessions
Okay, sir.
according to your convenience. There are three
Okay.
different TAs. In Saturday and in Wednesday session, you will not get me. There will be some other TA.
Okay, sir. Yeah. Thank you, sir.
Timing is same, sir. 4 to 6.
Yeah, timing is for Sunday it is same. For Sunday it is 4. I think for Saturday and Wednesday timings are different.
6 to 8. Yesterday it was 6 to 8.
Yeah.
And sir, what about the assignment? Actually, every week we have to appear in one assignment.
Yeah, that you will get at your NPTEL module, NPTEL that you will get at NPTEL. You have to submit that assignment. You will get one assignment every week, and there will be a end time for that assignment. You have to submit that before that.
Okay. So it is not mandatory. Every week we have to appear in that that assignment paper.
I think you can see the end date for that assignment. Before that, you have to submit it, because that those marks are going to replicate in your final scores. If you had registered for the certification, so those marks are going to replicate in your final score.
Okay, sir.
Okay, sir. So, like, sir, this second week session is going on. Like, I missed the last week because I was out of the town. So now I have to complete the first week session completely, then assignment as well. Then
Yes.
second week session, then second week assignment as well.
Yes. Because if you are not going to do the assignment, you are just going to lose some marks.
Okay,
So
sir.
it is necessary to submit it, I think.
Okay, sir. Sir, the first session I have not attended. So the assignment is pending, sir.
No, it's not like you don't have to attend the live sessions, all live sessions for submitting the assignment. For assignments, you have to just see the lectures. You have to see first week lectures. Then based on those lectures, you will get an assignment for first week. Just you have to put the answers in the portal itself. You don't have to make a pen and paper assignment. You just have to put the answers at the portal only.
So we have to upload, or sir, it is digitally we have to write there.
These are objective. There are objective types of questions.
There are
So
objective
just you have to
assignments.
mark
Okay,
the
okay.
answer.
No, sir, assignments I was talking about. Assignments, because I haven't attended any, till now any assignment. So whether it's going to be like on a digital platform, or we have to write down on the paper
I
and
will
we have to
show you.
upload.
Let me show you. You are able to see my screen, no?
Yeah, yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
So this is week 1 lectures. You can see there are around 6 lectures in week 1. Okay. Then there is one option for quiz. Week 1 assignment 1. Okay.
Okay.
So you just have to click it
Okay.
and it will open the assignment for you. Okay. So you just have to mark the answers here. Okay. You
Okay.
just have to mark the answers here and you have to submit answers. Just like that.
Okay. Okay. It's easy, sir. Yeah, perfect.
Yeah.
Fine. And sir, final जो certification exam is going to happen, that will cover the entire syllabus.
Yes, that will cover the entire syllabus.
Okay.
So any more questions or we end this session?
So I'll go through this, balance the syllabus and the chapters. Then I think I'll have the more questions on next session.
No problem. Okay, so thank you all for joining today. So we will meet again next Sunday 4 p.m. Okay.
Sure, sir.
Okay, thank you.
Okay.
Thank you, sir.
Thank you, sir.
Thank you. Yeah.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay, thank you.